Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. Now, the first thing I'm going to do is I'm going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x is 1, so I have 3 to the power of x times 1 plus 1 plus 1. Now this is equal to 1. Now 1 plus 1 plus 1, this is going to be 3. So now I have 3 to the power of x times 3 is equal to 1. And now from here, I actually have 2 methods to solving this problem. So for method 1, 3 here, this is the same thing as 3 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to 1. This is equal to a to the power of m plus n. So 3 to the power of x times 3 to the power of 1, that's going to be 3 to the power of x plus 1. Now this is equal to 1. Now 1 here, this is the same thing as 3 to the power of 0, because anything to the power of 0 is equal to 1. So now I have 3 to the power of x plus 1 is equal to 3 to the power of 0. And now, if I have something in the form a to the power of m is equal to a to the power of n, and this means that m is equal to n. So in this case, x plus 1 is equal to 0. Now I'm going to go ahead and subtract 1 on both sides, so these two cancel out, and I'm left with x is equal to negative 1. So this is my answer. Now for method 2, so I have 3 to the power of x times 3 is equal to 1. Now I'm going to divide by 3 on both sides. So now I have 3 to the power of x is equal to 1 over 3. And now, if I have something in the form 1 over a to the power of n, this is the same thing as a to the power of negative n. So in this case, I have 1 over 3 to the power of 1. And this is the same thing as 3 to the power of negative 1. And now if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to negative 1. Now to check, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. And we know that x is equal to negative 1, so now I have 3 to the power of negative 1 plus 3 to the power of negative 1 plus 3 to the power of negative 1 is equal to 1. Now, if I have something in the form a to the power of negative n, this is equal to 1 over a to the power of n. So 3 to the power of negative 1 is going to be equal to 1 over 3 to the power of 1. 3 to the power of 1 is the same thing as 3, so I have 1 over 3 plus 1 over 3 plus 1 over 3 is equal to 1. Now, 1 over 3 plus 1 over 3 is 2 over 3, so I have 2 over 3 plus 1 over 3 is equal to 1, and 2 over 3 plus 1 over 3 is 3 over 3. Anything divided by itself is 1, so 3 divided by 3 is 1, so I have 1 equals 1, and this is right. Alright, so I have 7 to the power of x minus 7 to the power of y minus 7 is equal to 2400. Now, first off, if I have something in the form a to the power of m minus n, this is equal to a to the power of m over a to the power of n. So 7 to the power of x minus 7, that's going to equal 7 to the power of x over 7 to the power of 7. And 7 to the power of y minus 7, that's going to equal 7 to the power of y over 7 to the power of 7. And this is equal to 2400. Now, if I multiply both sides by, well, first off, actually, before that, 7 to the power of x over 7 to the power of 7 minus 7 to the power of y over 7 minus 7. This can be written as 7 to the power of x minus 7 to the power of y over 7 to the power of 7. Because both the denominators are the same, you can simply just subtract the numerators with each other. So now this is equal to 2400. Now I can go ahead and multiply both sides by 7 to the power of 7. So now from my left-hand side, these two are actually going to cancel out. So now I'll be left with 7 to the power of x minus 7 to the power of y is equal to 7 to the power of 7 times 2400. Now, as you can see, 7 to the power of 7 times 2400, this is going to be a positive number, right? Meaning, if 7 to the power of x minus 7 to the power of y is going to result in a positive number, then this must mean that 7 to the power of x is greater than 7 to the power of y. And this means that because both of these two terms have the same basis, this means that x is greater than y. So now we can say that x is going to equal y plus k. And k is any integer. So now if x is equal to y plus k, we can rewrite x as, we can rewrite this as 7 to the power of y plus k minus 7 to the power of y is equal to 7 to the power of 7 times 2400. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 7 to the power of y plus k, that's going to equal 7 to the power of y times 7 to the power of k. Now I have minus 7 to the power of y is equal to 7 to the power of 7 times 2400. Now if I factor out 7 to the power of y from this, I have 7 to the power of y times 7 to the power of k minus 1. This is equal to 7 to the power of 7 times 2400. Now this gives me two equations. I have 7 to the power of y equals 7 to the power of 7, and 7 to the power of k minus 1 is equal to 2400. This is because, as you can see, this is in the form a term times a term, and this is the same thing, a term times another term. So that's why we made these two terms equal to each other, and we made these two terms equal to each other. So now, if 7 to the power of y equals 7 to the power of 7, then this means that y is equal to 7, because if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So y is equal to 7. And now I have 7 to the power of k minus 1 equals 2400. I can first start by adding 1 on both sides. So now I have 7 to the power of k is equal to 2401. And this means that because 2401 is the same thing as 7 to the power of 4, this means that k is equal to 4. So now we have both our values of k and y. And remember how x is equal to k plus y. So we know that y is 7 and k is 4, meaning x is equal to 11. So y is 7 and x is 11. Alright, so in this problem, I have 2 to the power of 18 minus 1. So, to solve this problem, for my solution, I'm going to first start by rewriting my problem. So I have 2 to the power of 18 minus 1. And let's first ignore the minus 1 here and just focus on this 2 to the power of 18. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. So I just wrote 18 as 9 times 2. And now an important property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, I have 2 to the power of 9 times 2, and I can rewrite that as 2 to the power of 9 to the power of 2. So, going back to my original problem with the minus 1, I get 2 to the power of 9 to the power of 2 minus 1. And now 1 is the same thing as 1 squared. So I'm going to rewrite 1 as 1 squared. So I get 2 to the power of 9 to the power of 2 minus 1 squared. And the reason I did that was because now I can use this property. A squared minus b squared is equal to a plus b times a minus b. So I have 2 to the power of 9 squared minus 1 squared. So a is 2 to the power of 9, and b is 1. So now I get 2 to the power of 9 plus 1 times 2 to the power of 9 minus 1. Now what is 2 to the power of 9? Well, 2 to the power of 9 is equal to 2 to the power of 3 times 3. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this is the same thing as 2 to the power of 3 to the power of 3. Well, what is 2 to the power of 3? 8, right? Meaning this is equal to 8 to the power of 3, which is equal to 8 times 8 times 8, which is equal to 512. So 2 to the power of 9 is 512. So now I get 512 plus 1 times 512 minus 1. So 512 plus 1 is equal to 513. And 512 minus 1 is equal to 511. So I get 513 times 511. And now there is a simpler way. Instead of multiplying these two using the normal method, like this, there is a faster and more efficient way to do that. And how are we going to do that? Well, I'm going to rewrite 513 as 500 plus 13, and 511 as 500 plus 11. So this way, I can distribute the 500. So I get 500 times 500, which is 500 squared, plus 500 times 11, plus, now I can distribute the 13, times 500 plus 13 times 11. Now it's much easier to solve this. 500 squared is 250,000. And 500 times 11 is 5,500. 13 times 500 is 6,500. And finally, 13 times 11 is 143. So now I'm going to add all these up. 5,500 plus 6,500 is 12,000. 250,000 plus 12,000 is 262,000. And 262,000 plus 143 is equal to 262,143. So my final answer is 262,143.